When you look up at the night sky, what do you see? You see countless stars. You see tiny points of light scattered across a vast dark canvas. It's easy to feel small. It's natural to wonder just how far all of that goes. Does it just keep going forever and ever? Or is there some kind of wall at the end of it all? This is one of the biggest questions humans have ever asked. It's a question that has puzzled philosophers, poets, and scientists for centuries. The universe is the biggest thing there is, and we are just beginning to understand its true scale. People often imagine space as a giant empty box. They think if you could travel in a spaceship far enough, you would eventually reach the edge. But what would that edge even look like? Would it be a solid barrier? And what would be on the other side of it? This simple picture is what most of us have in our minds. It's an intuitive way to think about boundaries and endings. We are used to things having a start and a finish, a top and a bottom. The universe, however, might not play by those same simple rules we experience here on Earth. The reality is that space is not just an empty void. It is a dynamic, active place filled with galaxies, stars, planets, and mysterious things like dark matter and dark energy. It is the fabric of existence itself. Thinking about its end is like trying to imagine what is north of the North Pole. The question itself might not make sense in the way we usually think about it. The universe isn't a container holding things, it's the thing that is everything. Exploring this concept requires us to stretch our minds beyond everyday experience. This grand cosmic question touches on something deep within us. It's about our place in the cosmos. Are we part of something that is endless and eternal? Or are we living in a finite, bounded reality? The quest to find the answer is not just about measuring distances, it is about understanding the fundamental nature of reality. It's a journey of discovery that pushes the limits of our knowledge and our imagination. Every new telescope and every new theory brings us a tiny bit closer to grasping the true nature of our cosmic home. So, what do we actually know? Scientists can't measure the entire universe directly. We have a cosmic speed limit, the speed of light. Because the universe is about 13.8 billion years old, we can only see light that has had 13.8 billion years to travel to us. This creates a bubble around us called the observable universe. Everything we can see, from the closest star to the most distant galaxy, is inside this bubble. This sphere of sight has a diameter of about 93 billion light-years. That number is staggering, almost impossible to truly comprehend. Now, that 93 billion light-year measurement might seem strange. If the universe is 13.8 billion years old, shouldn't the observable universe be 13.8 billion light-years across? The reason it's much bigger is because the universe has been expanding the entire time. The space between galaxies is stretching. So a galaxy that was much closer to us when it emitted its light is now much, much farther away. We are looking at its baby picture, but the galaxy itself has moved on, carried away by the expansion of space itself. This expansion is a key piece of the puzzle. It was discovered by Edwin Hubble in the 1920s. He observed that almost all galaxies are moving away from us, and the farther away they are, the faster they are moving. This doesn't mean we are at the center of everything. It's more like raisins in a rising loaf of bread. From the perspective of any single raisin, all the other raisins are moving away from it. Every point in the universe is experiencing this expansion. This discovery completely changed our understanding of the cosmos. The most important thing to remember is this: the observable universe is not the entire universe. It is just the part we can see from our position in space and time. The full universe is almost certainly much, much larger than our observable bubble. But how much larger? Is it just a little bigger, or does it stretch on without end? This is where the real mystery begins. What lies beyond our cosmic horizon is something we cannot see directly, so we must rely on cosmic geometry and theoretical physics to guess. Scientists believe the shape of the universe determines whether it is finite or infinite. There are three main possibilities for its overall geometry. The first possibility is that the universe is flat. In a flat universe, space behaves just like you learned in school. Parallel lines will stay parallel forever. If the universe is flat, like a giant, endless sheet of paper, then it most likely goes on forever. This infinite flat model is currently the one that best fits our observations of the cosmos. Another possibility is that the universe has a positive curvature. Imagine the surface of a giant sphere. If you were a two-dimensional creature living on that sphere, you could travel in what seems like a straight line. Eventually, you would end up right back where you started. In this kind of universe, space is finite but has no edge. It just wraps back around on itself. You could travel for billions of years in one direction only to find yourself approaching your starting point from the other side. It's a mind-bending idea. The third option is a universe with negative curvature. This shape is often compared to a saddle. It curves in opposite ways at the same time, like a Pringles chip. In a negatively curved universe, parallel lines would eventually drift farther and farther apart from each other. Just like the flat universe, a negatively curved universe would also be infinite. It would stretch on forever in every direction, but its geometry would be a bit more complex. The destiny of the universe, whether it expands forever or collapses, is tied to this shape. So how do we figure out which shape is correct? Scientists study the cosmic microwave background radiation. This is the leftover heat from the Big Bang, a faint glow that fills the entire universe. By studying the tiny temperature variations in this ancient light, we can measure the geometry of space on the largest possible scales. So far, our best measurements show the universe to be extremely close to flat. This provides strong evidence that the universe might indeed be infinite, but the measurements are not yet precise enough to be absolutely certain. The debate continues because our measurements are not perfect. While the data strongly suggests a flat universe, there is still a margin of error. It is possible that the universe is so gigantic that its curvature is simply too subtle for us to detect. Imagine an ant living on the surface of a massive balloon. The balloon's surface is obviously curved, but from the ant's tiny perspective, it would look completely flat. Our observable universe could be a tiny, seemingly flat patch on an unimaginably large curved cosmos. Furthermore, we must consider what lies beyond our observable bubble. We have no way of knowing if the laws of physics are the same out there. The part of the universe we can see might just be one small region with its own set of rules. This leads to fascinating and very speculative ideas like the multiverse. Perhaps our universe is just one of many, each with different physical laws and properties. This idea, while popular in science fiction, is currently impossible to test. It remains in the realm of theoretical speculation for now. Here's a fact to blow your mind. If space is truly infinite, then anything that can happen will happen. Somewhere out there, in that endless expanse, there would be another planet exactly like Earth. In fact, there would be an infinite number of planets exactly like Earth. There would be infinite versions of you, some living identical lives, others living lives that are only slightly different. This is a direct, if unsettling, consequence of combining infinity with the finite number of ways particles can be arranged. So, is space truly infinite? The honest answer is that we don't know for sure. Our evidence points towards a flat, infinite universe, but we can't rule out the possibility that it's just so vast it only appears that way. The universe guards its greatest secrets well. Scientists will continue to build better telescopes and refine their theories, pushing back the boundaries of our cosmic horizon. We are explorers on the shore of a cosmic ocean, and the grandest mysteries still lie waiting in the uncharted deep. What do you think is waiting for us beyond the edge of what we can see?